In this video, I will be going over lesson 19, which is about simulations for compound events. Here's our first question. It says that a coin is used to stimulate the probability of a parent having one boy and one girl if they have a total of 2 children. A heads represents having a girl and a tails represents having a boy. The coin is flipped twice for each trial. The first flip represents the first child and the second flip represents the second child. The experiment was performed 12 times and the results were recorded in the following table. Based on the simulation, what is the probability that parents will have one boy and one girl if they have a total of 2 children? So here, essentially what we're doing is we're looking at this table and we're counting all of the times where there is an H and a T, so 2 different ones. So we're not looking for HH and we're not looking for TT, we're looking for HT or TH and counting those. So if I look through my table, here's 1, 2, 3, 4, 5. If I look through the rest, they're all the same, so they don't count. So that is 5 out of those 12 different times they performed that experiment where they landed on different ones. So it looks like they'd have a 5 out of 12 chance based off of this simulation to have one boy and one girl. Our next question. So essentially there are 3 candidates running for student council, Greg, Brittany, and Eliza. And then there are 3 candidates for treasurer, so Trey, Fabian, and Paulina. I'm going to skip down to where it's asking our question. And the question here says, what's the probability of Greg or Fabian winning the election? Okay. And if I read up here, the first dice, 1 and 2 represents Greg. And then on the second dice, a 3 and 4 represent Fabian. So if I look, here's 1, 2, and 1. So these 3 different options represent Greg winning. That's those 1 and 2 that represent Greg on the first dice here. If I look, I see 1, 2. Those 2 dice rolls on the second one with that 3 and 4 represent Fabian winning. So they don't both need to win the election. It's just one or the other, right? So if I look, I have 5 different circles on my table. I have 1, 2, 3, 4, 5. So that means they have a 5 out of 8 chance of Greg or Fabian winning that election. And 8 is my total because that is how many total trials were done for this experiment. My next question says that a company is accepting job applications for a customer service position. In general, 75% of applicants are qualified for the job. What simulation best models this situation? So again, 75% of applicants are qualified. So we're looking for a simulation that represents 75% or has a majority of it to where that would work, okay? The first option here says drawing from a deck of cards where a heart represents qualified applicants and diamonds, clubs, and spades represent unqualified. Well, here the bulk of them represent unqualified, right? We have diamonds, clubs, and spades. That's 3 out of the 4 that represent unqualified, but they should be qualified. So because of the wording on this one, A here is out. B says rolling a dice where 1 through 4 represent qualified and 5 and 6 represent unqualified. Well, that would be 4 out of 6, which is not 75%. So because of that, nope. The next one says flipping a coin. Well, when you flip a coin, that's 50-50, right? Because you can either land on heads or tails. So that is nope, which means this bottom one is correct. And you have to make sure you read this one carefully because it's very similar to that first one. But here we can see if I draw hearts, diamonds, or clubs, they represent qualified. So that's 3 out of the 4, or that 75% that represent those qualified applicants. So read this one carefully. Our next question says that Erica plays for a volleyball team. In general, 10 out of 12 of her serves are successful. Which simulation best models the situation? So 10 out of 12 simplifies to 5 over 6. So because that denominator is 6, I'm thinking we're going to be rolling a dice. And the reason why is because, when I roll a dice, I have 6 different options I could roll, right? And my denominator is 6, so that's a total of 6. So right off the bat, I'm going to cross off these ones where I'm drawing a card. Let's focus on the 2 where I'm rolling a dice. Remember that 10 out of 6 are successful. Okay, so when I'm reading my 2 different options, I want to pick the one that represents successful serves, and it's the most. So the first one here says rolling a dice where numbers 1 through 5 represent successful serves. Well, this one's pretty good, right? 1 through 5, that's 5 out of 6 that represent successful serves, and there's only that one number that represents unsuccessful. So we found our answer. Our next question here says that if 2 different neighborhoods, 50% of the homes have at least one pet, which simulation could be used to determine the probability of choosing 2 homes at random, one from each neighborhood that are homes with a pet. Okay, so big thing to see in this problem is that we're doing 2 experiments, right? We're going to be doing we're going to be surveying people from 2 different neighborhoods. So flipping a coin once is not going to cut it because that only represents one neighborhood. I need it to represent 2. The first option here says drawing 2 cards, letting a red represent a pet or a home with a pet and black representing a home with no pets. This one works because I have a 50-50 chance of picking a red card or a black card. In a deck of cards, half the cards are red and half the cards are black, so that one works. B says drawing 2 cards and letting a face card represent a home with a pet. This does not work because a face card is not, you don't have a 50-50 chance of picking a face card from a deck of cards. And D here would work because I'm flipping a coin twice, right? So when I flip a coin, I have a 50-50 chance, and that matches the probability that I'm given in my problem. All right, last question here. It says that suppose a school has 2 movie clubs, one for 7th grade and one for 8th grade. In each club, 4 people prefer to watch science fiction movies and 2 people prefer to watch comedies. Which simulation could be used to determine the probability of randomly selecting 2 people, one from each club, that like the same type of movie? Okay, so again, we are selecting 2 people, which means these options where I'm rolling a dice once are out right away because I'm selecting 2 people. That means I need to do 2 different experiments. So let's read these carefully. Let's see. So 4 people prefer to watch science fiction and 2 people prefer to watch comedies. Okay. So rolling a dice and let even numbers represent a person who likes comedies and odd represent someone who likes science fiction. Well, this doesn't work because even in odd numbers on a dice, that's an even amount, right? That's 1, 3, 5 or 2, 4, 6. That's a 50-50. And here I have a 4 to 2. So I have a 4 to 2 ratio. So that doesn't work because if it was 50-50, it would have to be 3 to 3 where I have the same chance on each side. So this one's out, which means it has to be D. And D says I'm letting multiples of 3 represent a person who likes comedies. And if I think about it on a dice, if I were to roll a 3 or 6, that is a multiple of 3. So that is 2 different outcomes, which matches the 2 people that prefer to watch comedies from my problem. All right. And that is it for lesson 19. If you have any other questions, please let me know.